Volumes of spheres.
This week we're going to be talking about spheres. In today's notes, we're going to look at volume. The second set of notes is going to cover the surface area, and it's going to make sense why that one will be the second as we go through the notes, which is different than the order and how we discussed everything else beforehand. Okay, up at the beginning, the volume of a sphere is 2/3. It's 2/3 the volume of a cylinder that has the same height and the same radius. What I'm going to do in the notes is just discuss how we can take that fact and we can end up writing a formula that's for the volume of a sphere. But I do highly encourage you to watch the video. What happens in that is we take a cylinder with water in it, and then we show that the sphere of the exact same height and width of it takes up 2/3 of the space, and all that's done with water. Anyhow, here's a little picture diagram of what I'm sort of explaining here is that we have a cylinder that would be like the perfect container to fit that sphere. It has the same height and it has the same width of it. In other words, you've got a diameter for the cylinder, right? Because that's a circle base, and it's the same diameter that you would have for the sphere. But your height is also going to be that same diameter. Recall that the diameter is the same thing as 2r, because our formulas are going to be really just based in radius. I just thought it'd be nice to show you that the dimensions could be just simply called diameter. Okay, so what I'm going to start with is the volume formula for the cylinder, which is going to be pi r squared. That's the area of the circle base, but that then gets multiplied by the height of the figure, h. Now, with some substitution for our problem in particular, the radius is still the radius, nothing changes that part, but the height is the same thing as 2 times the radius. Okay, now all of that would be the cylinder. Okay, so if I want to start looking at the sphere, what I'm going to do is just multiply the whole thing by, so I'll just jump down to here, multiply the whole thing by 2/3. And again, that part right there, the 2/3 comparison, is something that you can watch in a separate video. That there's dozens of those out there. Okay, when the height is replaced with 2r, that allows you to have the same variable show up twice. And what we can do is group those variables together. The important thing here is that you understand what the relationship is between the r's. And in this case, it's multiplying. So you've got r squared, which is the same thing as r times r. And then you're going to multiply by a 2 and an r. Okay, so everything here is multiplication. It's not addition. If it's addition, that would be combining like terms, and the way you'd handle that would be different. But being that everything here is really just multiplication, I'm going to move some things around. I'm going to take that 2 being just a regular number and separate it from the r and just move it up to the front. Okay. And then I can just leave that r at the end. So the 2 went to the front, there it is, not the very front, but went to here, and then that r just hung out in the back. So these being regular type numbers, you can go ahead and multiply them together. Think of the 2 as being 2 over 1. Okay, 2 over 1, so then the 2 multiplies by that 2 and gives you a 4. The 3 is going to multiply by a 1 that we don't have shown here, so you get a 3. You have your pi symbol, and then r squared times r is really just r times r times r, so we can write that as r cubed. And that will end up being the volume formula for a sphere. Again, one more time, the 2/3, I don't justify why that's true here, but definitely go watch some videos on how that comparison is true, because we really want you to buy into it. But the end result is that this will be your formula for the sphere. For example number 1, we're going to do a basic type problem. You have a sphere, and we're just asking you to find out what the volume is. The formula, 4/3 pi r cubed. And by the way, this is one you should try and memorize like long term, because it's going to keep coming back in math classes. Okay, that being our formula, tells us that we need to know the radius. And just like a circle in the past, there's only one variable you really need to know, which is the radius. That's going to be the same thing for the volume and also the surface area when we get around to that. Okay, so you take a look at the picture. they tell you that from top to bottom is a 12, so that means that your radius is going to be a 6. So that teeny bit of side work that we tend to do a lot with circles, that happens here, okay? From this point, you're really just going to do the full calculations. I know that I've got the 4/3 is the pi. 6 cubed is going to be 216. 216 is divisible by the 3, so we're going to get a nice whole number from these. And the reason that we know that is because 6 is also divisible by 3. But what I'm going to do is just turn to a calculator and type that stuff up here. So we got 4 divided by 3, and we got pi, and then 216, or you could just type in this 6 cubed, but I know that it's 216, so. Oh, gets us to that. That would be it as a decimal answer. Let me take out, and this is kind of cool here to see. I'm going to divide, whoops, I don't want to do that. I'm going to divide by pi, and it's going to bring it back down to that whole value, which is what I really was intending to do here. Just multiply the 4/3 by the 216. Okay, so as answers, we get 288 pi, which I think is great. That'll be centimeters cubed since we're in volume. As a decimal, it's approximately 904, let's just call it 0.8. We'll go with 1 decimal there, centimeters cubed. So both answers, my preference might be to do these in terms of pi, but that's not like 100% preference. It depends on what we're really working on. So being able to do both is always important. Okay, example number 2, kind of a more challenging problem here, not just doing a calculation, but what we're trying to figure out is the circumference. It says the circumference of the largest cross section of a sphere if you have the volume. Okay, so if you got the volume, let's think about what the formula says. 4/3 pi r cubed. So if you knew the volume to be 972 pi, by the way, I've mentioned this in the past, but if you're provided a number that involves pi, that's because they're trying to set you up for a really good problem, like seeing the pi's cancel. But if we have the volume and we have the formula, then we should be able to figure out what the radius is, right? You should be able to, look at this picture here. You should be able to figure out what the r value is by just working backwards. Now, they don't want you just to stop there and say, well, what was the r value? They then want you to use that to continue and find something new. In this case, it asks for the circumference of the largest cross-section. It's important that we do mention that it's the largest cross-section here so we know what slice we're looking at. So I'll go back to this picture. This, what is shown right here in the middle, that is the largest cross-section. So that's what they're talking about. But you could slice in any other place. We did this with cross-sections beforehand. You could slice in other areas and you get small circle cross-sections that have what would be smaller circumferences, smaller areas in them. Okay, so they do want the largest one, which means that if we solve for the radius here, you are getting the radius that we need. Okay, now I'm going to jot down over here that circumference is 2 pi r. So when I get my radius from here, I'm just going to end up plugging it into this part. Okay, so the pi symbols, they just cancel from the beginning. You don't really worry about that too much. Okay, now here's how I get rid of fractions. This is just the rhythm that I do, and if you have a calculator, it's fairly easy. I take the 972 and I multiply it by the denominator 3, then divide that answer by 4. You may have been taught that you multiply by the reciprocal of the fraction, and that's pretty much what you see here in the 3/4. I just always found it, because you find ways that are just like a rhythm and a systematic way for yourself. So I always found if I just take that number, multiply by the 3, divide by the 4, and you can even see on the calculator, it looks like a 3/4. It's just a different way of thinking about it, and it gives me kind of a step-by-step process. So if I had numbers that weren't that large, I could actually just do that, like as mental math fine, without needing to think of it as a fraction. Okay, so we're going to take a cubic root of that, and you might not recognize that number, so we'll just type it up. It's been a long time since I've had to use this calculator, so I'm trying to remember where all the features are. But I'm going to recall the cubic root, and you can do all this on a regular cell phone calculator, by the way. 729, and you're going to get back exactly 9. So now that goes along with what I said at the beginning, where if we give you something in terms of pi, we're trying to set you up so that your numbers are going to look good later. Okay, that is now going to head over to here to calculate our circumference. The 9, I might as well just multiply it by the 2, and we can call this 18 pi. Okay, and circumference is going to be a one-dimensional measurement. So if this is centimeters cubed, that means that your circumference is just centimeters. If it was the area of the cross-section, then it would maybe be, centimeters squared. But of course you do a different formula. So that'll work as an answer. If you do want to multiply it by pi, it comes out to be 56.55 centimeters. So perfectly good answer as well.